Hello everybody, in this video we're going to be going over how to create this effect that we have here, basically having a cannonball type of object hitting a wall and destroying it and having it all crumble down and look awesome. We are going to be using rigid body dynamics to achieve this and then fracturing it and modeling it all out, so I hope you guys enjoy the video. Okay, so let's get started breaking stuff. I'm going to create a geometry node. And inside of this geometry node, I'm going to create a box. There we go. And this is going to be like a wall that I'm going to break. I also want to create so let's call this wall. And then I'm going to create another geometry node. And this one is going to be the ground. And inside of here, I am going to create a grid. There we go. And I think that's big enough for our purposes. So let's go back here to the wall geometry. And I am going to create a transform. So that way I can, well, I can do it inside of the box, but I like to have the pivot where I can control it a little bit easier. So here with the transform, I'm just going to move it up some. And then let's move it back some on the Z. There we go. And then I am going to scale it. Oops, that's rotation. I didn't mean to rotate, I want to scale. There we go. So I'm going to scale it vertically here. And then I'm going to scale it side to side, which will be on the X. So that way we have a nice big wall. So now that I've done that, I'm going to go to the original box node, and I'm going to turn it into polygon mesh. Going on the depth here, I don't need those extra polygons, so not at 1 but at 2. I'm just going to make it kind of thick like that. And then on these two, I'll increase it maybe to like 30 and 30. And then now that this is wider, I'll probably want maybe to increase this a little bit more so that we have more kind of square type polygons rather than having more rectangular ones like we do have here on the side. I mean, it's not going to make a huge difference, but I want to be able to have some control here on the wall to be able to control it and have it be able to fracture the way I want it and be able to paint some stuff onto it on the points and things like that. Let's give ourselves a little bit more room, and then I'm going to push this up, and I'll use P on the keyboard to bring up the parameters rather than having the other one up because it just takes up too much room for the tutorials. Okay, so now that we've done that, I want to take a look at fracturing this and kind of getting my initial breaks of the wall. And I want to kind of get a general idea of where I want to impact. Well, I know I'm going to impact the wall around the center, but I want to make sure that my fractures don't necessarily go all the way up to the edges. So to do that, I'm going to do a Voronoi Fracture. And in here, it requires a piece of geometry in the first input. So we got that. And in the second one, it's going to require a set of points. So in order to get those points, oops, it's not going to work that way. let's break that. So I'm going to push Y and cut that. And what I want to do is create a scatter node. And when we look at that, we get a whole bunch of points. And then I'm going to decrease the total count to something like 5. So we got way less points now, but it is going to allow us to kind of get big fractured sections of our wall. So you can see you have 1, 2, 3, 4, 5. And that works out well for what I need to do, but looking at the center here where I want it to impact, I want to have one piece there, and it didn't turn out that way for the shape I created. So what I can do is over here where it says global seed and the parameters for the scatter node, I can move this around and kind of get one that is working a little bit better for me. And maybe I can find it, maybe I won't be able to. That could be kind of interesting. That would be like the whole top section if I wanted it. I kind of want it more in the center, so maybe I'll drop down the number of points. I think if I were to keep it the way it was, I'd eventually get it, but here I can get probably a little bit quicker. So here this looks kind of interesting, the whole top section, but I want to see if I can get more of the middle here. Oh, I'm adjusting the number of points. I want to adjust the seed. That's what I want to do. That could be kind of interesting. So just go through and find one that you find that you like for where you're going to want to break your geometry. That could be kind of cool, so that the whole top section stays, but the bottom's going to be breaking. I think I'm going to have this one. I really like this shape here. So then looking at here, we can see that on the Voronoi Fracture node that we have where it names the pieces. So that's kind of cool. And then we get the names of the inside and outside pieces. So I'm not going to worry too much about that yet, but I do want to kind of separate this into 2 areas. So I'm going to create a blast node. And let's connect this one here, and then we can go into the group for the blast node, and you'll see that it has each one of the pieces. We have 4 pieces, so it has piece 0, piece 1, piece 2, piece 3. It starts at 0, that's why it doesn't end at 4, but there are a total of 4 pieces. So if I go through and select that, we can see that it gives us different pieces. And I want to make sure that I do everything except piece 2, it looks like, because that's the one I want to break. Then let's copy and paste this node. And I actually like it organized better this way. It doesn't really matter, but it's just what I like. So I could go in and deselect everything and be able to reconnect it through here, but we can also do the delete non-selected. So when we do that, oops, not on that node, I want to go on this node and turn on the display flag. Okay, cool. So when I do that, it reverses the selection and it blasts that piece only. So I have this piece that is going to be the part that I'm going to be breaking into smaller pieces, and then we have this that is going to be our original, or our non kind of broken area. So now that I have that, I'm going to add a null node. And in this null node here, I'm going to rename it into be out static wall. So we're going to make this into a static collider, and then this is going to be the rigid body. Cool. So let's work on this piece here and try to make it a little bit better. So now we can do the Voronoi Fracture. And we can kind of do something similar, but there'll be some issues, and I'll show you why in a minute. So I'm going to do a shatter, or sorry, not shatter, but scatter. Scatter node, connect that, and then connect this, and display this flag. So we can see we get a whole bunch of little pieces in here, and they all fit within this wall. Later on we'll put them where we can see them both together. But if I were to go into and create an exploded view node, what the exploded view does, it lets us visualize a little bit what all the pieces are. And you can see that we have pieces on the top and each one of the sides, but when we go through in the center, there's not really any pieces that are actually in the center. Like one side meets up to whatever is on the other side, and they're all pretty evenly spaced and things like that. So there's a few options that we can do to make this a little bit better. So let's move this a little bit down, and I'll put the display on that. So let's cut this first. And what I want to do is create a Voronoi Fracture point ahead of time here. So if I do that and connect this into the impact points and then connect this into the geometry, we will see that we get this shape here. And let's visualize some of the points. So we have surface, interior, and exterior. So if we were to look at the surface points and increase that, you can see those are the yellow points. So if you want more surface points, you can increase that number. And then if we look in the interior, we can increase that, and then you'll see that they're the red points. If we go to the exterior, it does have an ability to increase that, but in this case I don't want to have that. I just need surface and interior points for the Voronoi Fracture. So I can connect this, and if we go here and down to the exploded view, we can see that now there are actual like inside pieces, which is great. I still have the problem that we were looking at before, that they're all generally the same size, and typically when you have a collision, your impact area is going to have a greater concentration of smaller pieces, and as it goes out, it's going to have bigger pieces away from the impact area. So let's see if we can change that a little bit. I'm going to jump back to here, and actually I'm going to go all the way here. So what I want to do is be able to tell it where I want to add more points, and what I'm going to do is be able to paint a mask directly on this using the points that already exist. So I'm going to go in, and first let's create a point SOP, and I'm going to use the old one. And then here what I'm going to do, where it says keep color, switch it over to add color, and then right click on add color and go to delete channels. So if we display that, now this should be black. And then after we've done that, kind of move this down a little bit. We can go in and create a point SOP, or not a point SOP, sorry, a paint SOP, so that we can actually paint the details that we want. So right now its foreground is white, which is great. And let's make this, I got the lock on, let's turn that off and, oops. Go back and go here, will it give it to us? Let's go here, does that, there we go. So if we select this tool here, the show handle, that will give us the brush, and then we can use the middle mouse button wheel to make it bigger or smaller. And then let's just say that I want to kind of paint something like this. This is going to be kind of our main area where there's going to be the paint where I want the collision to happen. And then I think that is going to be, let's smooth this maybe a little bit so that way can extend that. Nope. Okay, apply to all, let's do that. Yeah, I like that better. Just so that kind of falls off as it goes through. Okay, so now that we've painted our mask on the geometry, and if we wanted to, we can even, oops, that's not what I want to do, in the back before we move too much further, kind of paint that same area and then switch over to smooth and apply to all, just so that we have that soft selection of points as well. Now let's go in and add a scatter node, and this scatter node, by default it's going to look kind of similar to what we had before, but it has the painted values there, so it's reading that we have painted that area. It's just not applying it just to that area. So the way we change that is where it says the density attribute, we can turn that on, and instead of assigning things to density, since we painted this map, we can do CD, and that will give us just based off of the color. And then we can increase or decrease the number of points, but you can see that there'll be more points in that section there, in the impact area that we're creating, than everywhere else, and it kind of falls off away from where we painted white. Okay, so let's look at this scatter here, and we get the Voronoi points. That is good there. We can see that it still has that painted value. That is okay. I'm going to turn off visualize points here. But what I want to do is maybe take these points and decrease the number of points overall. So as we go further away, actually let me see that. So let's increase the, oops, that's not what I wanted. What I wanted to do is, let's go to the scatter the way we had it before. So we got the shape. And then let's go to the Voronoi Fracture. That's what I want to do here. And points per area, we can decrease this overall so that way we have less points. And what we can do is merge. So what we're going to do is merge these points together with the dense points that we created. So when we look at that, we have a more dense area and a less dense area here. And we can maybe make it even less dense. And then just check this, and that's looking a lot better. And then make this connection into the Voronoi Fracture. And let's visualize this. And you can see now, as we go out towards the outside, there's bigger pieces, and in the center there's a lot smaller pieces. So that is exactly what we want, and then we can visualize this if we wanted to, and you can see pretty quickly that that is actually what happened. Okay, so I don't need this node anymore. That was just to kind of show you what's happening. And this is going to go all the way to the bottom. And this will be, let's create another null node. And we'll say this is our out rigid body. Geo. So this is going to be the geometry that we're going to actually deform, or not deform, but make dynamic. So let's go into the main scene. So obviously in the main scene we only see that piece because that's what we're visualizing, and eventually that's what we want. But I need to create another geometry node because we want to see the rest of the wall as well. And let's go, this is going to be our static wall. And since we're naming this our static wall, let's name this dynamic wall or something like that. Perfect. And then in the static wall, what I want to do is create a merge object, or an object merge node. And in here, we're going to go in and select, and we're going to look at the dynamic wall, and we're going to find the out static wall. Accept. You can see that it brings that there, which is perfect. So everything is working the way we want it to. Now we're going to need a object to collide with all this. So let's make that really quick. I'm gonna create a sphere for that. And let's call this, let's say it's a cannonball. And now that we have that, I'm going to go to create a transform. Oops. There we go, push this back and have it something like this. There you go. So we're going to shoot it forward, and hopefully it will hit the geometry in the spot that we want it. If not, we can make some adjustments, but I think this will be pretty close. If not, we can move it down a little bit or something like that. So now that we have all of this done, maybe this grid, let's go to the ground, make it, no, I'll leave it at that size. Okay, so now that I have made these adjustments, let's start making things dynamic. Going to go to the select the ground and collisions. This is going to be a static object. The static wall is also going to be a static object. Now that we have those, I'm going to go jump over to the rigid bodies and the cannonball. That's going to be a rigid body. And then the dynamic wall, that's going to be an RBD fractured object. And packed is fine. So let's look at our Autodot network. And before I go too much further, I'm going to save now because at this point it potentially could crash, or at least more likely to. Desktop CGI nerd, and we'll do a wall break working. And then this is going to be my wall file. Accept. Great. And then I'm going to push L here in the scene view, or in the node view here, so that way it lays out everything for me. And let's, before we start anything, just push play and see kind of how everything goes. Well, that went through the static wall. The problem that we have is if we look at the static object and we show for the wall, we show the collision geometry, it's going all the way through and not giving us space for that. Even though we have individual sections, it's not considering it a convex hole. So in order to fix that, we can check this checkbox here that says create convex hole per set. And then if we go back to frame 1 and then play this, we should see that the collision will actually interact with everything the way it's supposed to. So just the collision object just couldn't figure out this convex area, so it is separating everything for us now. So that's great. It's working exactly the way we want it to. We have the sphere here that fell down, so let's hide the collision geometry just so that you guys can see the ball. The cannonball is actually working. Great. So let's make the cannonball actually interact with that. So if we select the rigid body for the cannonball, we can actually go to its initial state, and we have a set of velocities for each direction. So we want it to move in the negative z. So let's put, say, -10 to start off with. Might be too fast, but we'll try it out. So now you can see that it's actually moving forward. And obviously a little bit lower than where I want it. I want it a little bit higher where it hits, so let's try -20. And it is hitting a little bit higher than what I want, but the amount of force might be okay. Let's try -30 just to see if it goes faster. What does the collision actually look like? Boom. And I like that it's kind of going through and falling through rather than kind of bouncing off. Everything's kind of falling backwards, which is not that great, so maybe I will keep it at a lower speed. Let's do -15. That way we can actually see kind of some of the stuff falling forward. Some of it is, but most of it is not. So let's try that now. So now we have more pieces kind of coming towards the front. And a lot of stuff just falling down into infinity, which is okay. But I like that it's actually like falling forward now. So that's a lot better than what we had a moment ago. Okay, and then I am going to go in and let's go to the overall scene here, and we'll go to the cannonball, and we're gonna move it a tiny bit down. So maybe like 4.5, so it's a little bit lower. And let's rerun this simulation to see where it hits. and how the breaking happens. So hopefully it hits like about right there. That is pretty spot on where I want it. Let's look on the front view to see if it's, yep, that's exactly where I want it to be happening. A lot is falling off the back, but towards the end we're getting a lot coming towards the front, so I'm happy with that. Maybe we'll actually expand the grid. So let's stop this really quick. And on the ground, let's scale this up. Seven, 8, 9, 10. There we go. And let's try this again. So now the pieces should just fall there rather than falling down into infinity. And we're still getting the stuff falling forward, which is what I want. Great. So I'm liking this look a lot more. It's going to change quite a bit by the time we finish, but one of the things that you can kind of see, let's just kind of pause it beforehand. So right here it looks like a solid wall, but as we start going, you can see that it's already being affected by gravity and starting to break and fall apart. And we really don't want that to happen. So let's take a look at making that a little bit better. So let's go into the Autodot network. And what I'm going to do is select the dynamic wall, and then I'm going to click on glue adjacent. Select the RBD object that we want, and then push return. So that's going to add these nodes here. They're kind of glue constraints, and let's look at it from a default perspective now. So you can see that it breaks on the impact, and it also starts breaking on its own weight, which is not exactly what we want. We just want it to start breaking once we hit it. So we can go into the glue strength here, and we could try maybe just increasing the glue strength and see how that goes. And it's not even making a dent on it. We can go into the cannonball maybe and see if we can go into its physics panel and increase its density at a few zeros. It should make it quite a bit heavier now. And we can see it does affect it, but it starts flying away, which is not quite what we want either. Because we want it to stay there, we don't want it to go away. So, and we want it to kind of break and start falling apart. So let's bring the density back down, because the original break was happening okay. There we can see that it is moving, but it's staying together. Let's go to the glue constraint. So something that we can do that is kind of a cool trick is let's take this and put it to -1. So when we have it at -1, you would think that it would start falling apart really easily, but what it does is actually keep everything completely together, because it is because it's unbreakable now when we put it to -1. Whereas if we had it at 0 or anything higher, it should kind of start falling apart pretty easily. So you can see that it's all falling apart already. It's kind of like what we had originally. Okay, so let's take the strength and put it back at -1, which will give us the wall completely staying intact. So if it's staying intact, we want it to break only where we hit it and keep everything else together. How do we do that? We have this node that when we created the glue constraint, or by using the glue adjacent tool here, it created this remove broken node. We have two nodes. One is the geometry here, and that is basically in the center of each shape. It is creating a point and then it's connecting them together, and those connections are what create the glue bonds or the glue constraints. And then here we can delete things as they are broken or when they break. I'm going to actually create my own delete node, but basically we just need to be able to delete these shapes as we need to. So I'm going to do this by doing a kind of like a geometry or a point mask. So I'm going to create an old point node and then connect these together. And I'm going to add color, and then I'm going to delete channels so that way it's black. Then I'm going to create a second geometry. Let's create a sphere, since the shape that is colliding with it is going to be a sphere. There we go. And then this, we're going to add a point, oops, not a copy to point, but a point, an old point node, just like we did with the other one, but this is going to be white, so we're going to add color, and then we are going to delete channels. Here we're going to select white, and then what we want to do is basically get this so that we can animate it and transfer the white points over to the other object and then only delete those white points. So what we want to do is go to create a transfer, an attribute transfer. And this is going to be the main geometry into the first input. The second geometry is what we're going to be transferring. And we can see it transfers all the color over. It's probably doing it way too early. Well, it's definitely doing it way too early. So what we want to do is to get this attribute transfer, because we can see that the sphere is still kind of far away from it. And maybe the sphere can be a little bit smaller. Something kind of like that. And then let's look here, it's still too long. And then we can go to the conditions inside of the attribute transfer node. And what I want to do is the distance threshold, decrease this. So you can see as we decrease this, it gets smaller and smaller, the influence. Say we keep it maybe at 2. And then we'll adjust it if we need to. Let's add a transform node. And then now with this transform node, we can animate it going across. If I can select the handle right, there we go. And as we animate it, it's going to destroy that section of the wall. I want to make sure that it is kind of lined up the way I want it to be, where I want the breaking to happen. As I go through, we can see that it's deleting quite a bit, almost everything. So I'm going to take the distance threshold on the attribute transfer and bring this down so that it's kind of more encapsulated close to the impact area. So that way it's kind of only breaking that area, and we can adjust it to be more if we need to. The next thing we need to figure out is exactly what frame it's going to be hitting on so that we can break it by then. And let's go to the object level, and we can see by simulating this Oops, I gotta put my glue constraints back on, so, but you can see kind of what frame it would still collide at. So if we break it by frame 11, we are good. Okay, so let me go back into the Autodot network. You can see that my glue constraints are off. That's going to be -1. And then going to go to remove broken, and at frame 11 is when I want this all to break. So here I am going to key this transform node in the translate, and then at frame 1 take it and animate it away, something like that, and then keyframe it. So now we should see that it will kind of move and animate going through. It should not change anything with animation except that I adjusted the glue strength so it shouldn't fall apart. Boom. So it just bounces right off. And then let's get it to actually delete. When we blast it, we're not going to want to blast the points. What we actually want to do is blast the primitives. So right now we've painted everything onto the points, and we need to promote that to go onto the primitives. The way we do that is create a promote, an attribute promote. There we go. Connect that. And we're going to take the color of the points and put it into the primitives. Then we want to create a blast node or delete. And then what are we going to delete? We are going to delete anything that is using the attribute color. So the capital C lowercase d is greater than 1. So anytime, or not 1, but 0. And let me make sure on the promote, yeah, we promoted the color. And we're taking it, and whenever it is greater than 0, it is going to delete. So let's see how that works. We can see that it deletes the connections there and the glue strength. So let's go back to the object level and see how the destruction looks now. Oh no, it's not breaking. So let's see. Here it's colliding at 11. Okay, let's go back here. It does have a warning. Let's look at the warning glue. Cache results are incorrect. So let's try going over here and just tell it to reset simulation and see if it actually works. Yes. So that worked pretty well. It kind of bounced off the bottom a little bit. So what I want to do is go back to the glue strength here, and maybe on this transform node on frame 11, just move it slightly lower. Oops. And let's see if that will, so I'm gonna set a keyframe here. And let's make sure. Okay. Then I'm gonna go back to the object mode and let's reset the simulation again. And we'll play it through. This time it did kind of bounce through it, but it kind of kept everything the way we wanted. everything broke, and potentially it could actually break more in that area there. And that's looking pretty cool. So now that we have that, I'm going to go to the Auto.network network, and if I wanted to, I can play with the density. It was at 10,000 1,000, and I put it to 10,000, I think. So let's see what it would be at the default of 1,000. So it kind of cracks it, but it doesn't completely destroy it, which is kind of interesting if that's the effect you're going for. And actually, maybe eventually it will fall over. It looks like it's going closer. It's going closer. I think if we were to let it run long enough, because now gravity is taking hold, it's actually going to fall over. So that's pretty cool. So if you wanted it to kind of just make a crack and then have it be able to spill forward, because I only want to have one camera angle. I don't need to have a bunch of camera angles or anything like that. This could look kind of interesting. Maybe I'll do something in between, like 5,000. See what that looks like, and you can play with the physics settings and get exactly the look that you want. That's kind of fun, like it went into it, but it's not like all the way through. And what was it like at 10,000? 100, 1,000, 10,000. Okay, let's look at that and play it through again. I like kind of seeing it go through the whole object. That's pretty fun. So I'm going to leave it at 10,000, but you can play with the amount of density with the objects and see what kind of effect you get and what you like best. And right now I'm just working with the cannonball, but the wall itself even has some physical attributes, so you can actually play with this. So let's say the wall was also had a density of 10,000. And it should give us kind of a, actually really similar to when it was 1,000 and 1,000. So I'm gonna maybe try 5,000 here and then resimulate it and see if we get much of a difference. I like the way it kind of jumped out there, and this will eventually fall over as well because gravity is going to take over. I'm going to put this back at 1,000 because I did like it going all the way through, and that worked well for me. Seeing it go through the object like that, perfect. Okay, so let's take a look at adding some materials and getting this set up for rendering. I'm gonna go to lights and setup here, and let's set up kind of a camera angle that I might like. Something kind of like that, and it says no camera. Let's create a new camera, so it'll be based off of this. And oops, let's go back to camera 1 and let's lock it so that way camera moves with us. If we go to the camera here, we can play with its settings, view. Can render it here for that view, or I can render it, I'm going to render it at 800 for 800, and I'll set it up to be able to be rendered for my Instagram And then the focal length right now is at 50, so let's try 35 and see how that looks, and then move the camera in so we have kind of a wider view. Hey Potter, my dog's here. He was sleeping this whole time. Okay, so let's play this and see kind of how it looks, and I want it maybe kind of a bit lower of an angle, so that way we have a more kind of dramatic angle, and I want to make sure that I still get it kind of coming to the edge, from the edge. Boom. That looks pretty cool. I mean, if we wanted to, we can even put like the camera maybe like way up here, so that's super dynamic. Let's see how that looks. That's pretty awesome. And kind of put it like that, and it's kind of want stuff coming right into the camera. That's pretty cool. Get some depth going on. And let's play that. Pieces coming straight into the camera. I like that, so I'm going to unlock this so that way I'm not going to move this camera on accident for my rendering. Then I need to set up lighting. So I'm going to create an environment light. Let's stop this from calculating really quick. The environment light, let's go into the render view and we'll render this frame. So that's looking okay. If we wanted to, we can maybe take up the intensity a little bit. We can also, I don't want a black background, so I am going to tell it to render light geometry. So that is a lot better. And then we can apply some shaders to all of this. So let's go into the dynamic wall setup here, and then we can do, let's push L to lay out everything, and that moved it in a crazy way I don't want it to. Let's keep this over here. That is our static wall out. And we're going to, if we look at our Voronoi Fracture here, oops, I don't want to do that, sorry. I just want to click on it. We have the inside and outside group. So the inside geometry versus the inside that has been fractured. So we can use those groups to assign materials to. So I'm going to create a material and another material. There we go. So I'll connect them in a minute, but I want one to actually be under groups inside, and then the other one's going to be outside. And then I'm going to copy and paste these here. I'm going to push Y, and then I'm going to connect this over here. And let's put it right before the outrig and see if that works there. I want to get both of these, connect that there. And we'll test it out. I think I'm going to have to change something in here anyways, but this will start getting us started. Let's create some materials. Going to the material palette. I am just going to create a couple of shaders. And then let's make this one our inside shader, and then our base color, let's make it kind of bright orange, like my content for my branding, and that looks good. Let's go back to the material palette, and this is going to be our outside. And I'll make this black. So that looks cool. Obviously we haven't applied anything here yet. The outside is going to be applied to the ground, so I can just throw that directly onto the ground. You can see how that changes there. Perfect. Then let's go into our tab over here, which was the object scene, but it changes it when we start working with the materials to the matte scene. I want to go back to the object scene. That is great. Let's go into the dynamic wall where we added the shaders, and then here this is inside, so on the material we can tell it which material we want to connect to, and it is going to be under matte and inside accept, and we shouldn't see anything there, which makes sense because it's all on the inside right now. And then outside we're going to take the material and do the outside material. There we go, and that changes. That's perfect. And here's where the problem may arise. So let's try inside really quick, which we can't tell if it worked yet, but here when we go to outside, oh, it did work. Okay, so in previous versions we had to make some changes, but it looks like in version 17 it fixes it for us. So let's look at our scene view really quick, and actually before I do that, let's stop the render because I don't need to render all of this. And up here is where we are possibly having the issue. Yeah, you can see that it is using the gray shader, which is not what we want. And let's check on the render to make sure that it's actually the gray shader and it's not giving us the materials that we want, but if it is, we'll just keep it that way. Nope, it's actually working exactly the way I want it. Visually it's not looking correct inside of the scene here. If you wanted to fix that, we can. Let's go into the dynamic wall here where it's the DOP import. We can change fetched geometry from dot network, and then we can say fetch unpacked geometry from dot network, and it should give us the colors that we're expecting. So if it bothers you in the viewport, you can fix it that way. We get the collision, and it all works the way we want it to. The last thing that I want to assign is that this object here, the cannonball, I'm going to go to the material palette and I'm going to make it the inside color as well, just to kind of make everything thematically accurate and everything's working correctly. That is great. And I'm going to set up a render really quick for this. So I already have the mantra node. I'm going to go to rendering. I'm going to allow for motion blur, and I want things to actually blur when I am working, because right now if we were to go to a frame where we can see, like, this should likely have motion blur coming into the scene, we can check the render really quick. We can see that there's no motion blur. So let's go to our object level, and on the camera, I believe we can select that, and sampling. Nope. Okay, let's check on the cannonball. It might be there. We go to rendering, then sampling. Yeah. So here we can see velocity motion blur. It's set to no motion blur. So let's turn this on here. So once we do that, we can see that it is adding some motion blur to our object. That's great. And then on the dynamic wall, I'm going to add that as well. So render, then go to sampling and turn the velocity blur on. And if we go to a scene kind of further on, we should see some of these pieces start having motion blur as well. So I'm going to stop this now, go to the scene view, and I am going to save my scene. Make sure to save because you don't want this stuff to crash. Switch over to the out network so that we can see our render. Let's look at the render settings right now. It is just rendering the current frame. I want to do a frame range. That is great. Then I'll render to end play, but let's simulate this all the way through just to see if I need the whole sequence or if I can actually stop it from rendering before it hits 240 to save myself some time. It looks like maybe it will stop before then, but we got these little pieces up in the section here that are kind of settling in and might kind of tip over. Looks like more pieces are going to fall, so it's going to use up the whole timeline. We'll do like 10 seconds. And we can render out more if we needed to, but I think this is definitely going to be long enough for my sequence. Maybe I want to extend it a little bit more. Nope, I'm happy with that. So it's going to go all the way through, and those little pieces are actually going to hit the pile, and then like immediately it will stop the render. Kind of looking at it closer to real time now. So that's what we got with the render, and I like a lot of it. There's some of these pieces, they're like really long, so I wish I would have maybe put more smaller pieces in the inside, but I think this is good enough for the example that I'm doing in this video, because I really like these little pieces when it starts off, but then a lot of these other pieces are just so long and they look a little bit unnatural. So you could increase the number of interior points in the Voronoi Fracture points to be able to achieve that. But I'm going to end it here. So I hope you guys found this helpful, and we'll see you guys in the next video. Bye.